Alright guys, here's a little help video for tonight's homework, study link 7.4. Don't get too stressed out about, I know there was a lot of stuff with like shapes and everything during class today, the journal pages. Probably a little bit more than what you need for this particular assignment. This one's all about just breaking things down into equal parts. So what you want to do here, look at the example first. They start with squares A, B, C, and D all divided in half. Okay, so at least exactly half of the shapes are shown here, two different colors. Half of this shape orange, half of this shape red, half of this shape orange, half of this red. Now, notice that the concept of equal parts doesn't have to look the same. There's different ways to make fractions look when they hold the same value. That kind of goes along later when we talk equivalent fractions. 1/2 is the same thing as 2 out of 4 parts, and that's the same thing as 4 out of 8 parts. Those are called equivalent fractions. They all mean half of the figure. So that's why these things can look physically different and still have the same value. The important thing on this is that when we look at this, you've got that value that's identical. You can see in the very first one, you would have, let me clear this off, you would have 1, 2, 3, 4, 5, 6, 7, 8 boxes that are in that half. So when you plan the rest of this out, you got to make sure you have 8 boxes. Here's 1, 2, 3, 4, 5 whole, 6 whole boxes. These two together make a 7th box, and these two together make an 8th box. So you can see that it's still going to be half. Over here we got 1, 2, 3, 4, 5, 6, 7, 8 boxes as well. So although these two parts look visually different, it's still 8 boxes to 8 boxes. So now take a look at number 1. Square E is into fourths. If you divide these F, G, and H into fourths their own ways, they can look completely different than the first one. The important thing is you just keep it into 1/4 of the original square. You can see what I did with the first one here by just going into vertical bars. Over here on the original example, it was 4 boxes per fourth. I still have 1, 2, 3, 4 boxes here. All of those bars, so each one is an equal fourth of the entire square. Looking at shape H, you can see that I have 2 whole figures, then this guy and this guy together would make a third, and these two together would make a fourth. So we still have our 4 boxes, but when you go angles, it kind of gets tricky. Now they don't have to be angles. You can do some weird figures like they did on these things here. Notice these are not the same 2 shapes on this side and on this side. So I'm going to do a kind of an odd shape like that. I'm going to make each shape look exactly the same, like a little L looking thing here. And now I'll come down. I should have used a straight line tool on this. I'm going to do all that again with a straight line tool. Let me turn my opacity up. Okay, so I'll come across here. Whoops. Then I'll go up. Okay, that's why I was using the pen, because that doesn't want to work for me. And we're back. And now I can split this right here, and I get the same little L shape. It's just rotated differently, but we still have our 1, 2, 3, 4 boxes that make this thing up. Okay, so those are 4 different ways to make the fourths. The next job is for you to make different ways to make eighths. Now the first thing you could do is start by kind of turning these sets of 2 in a vertical pattern. And then you can kind of map that out across the whole grid. Try it out. You know, you could do something with angles like this guy did. Boy, that's an ugly arrow. You can do something with angles like I did on this one, but you can also do something with odd shapes like this. Or you can do something that's completely different as long as it has the correct number of boxes in each section of the fraction. Now down here at the bottom, the word problem is, it's a good word problem. It's challenging, multi-steps. It's a lot of information that you kind of have to weed through. Rosa has 15 quarters, 10 nickels. She buys juice from a store for herself and her friends. Juice costs 35 cents per can. I'm going to put a box around this, but I'm going to be using it later. I got to do some other prep work first. She gives the cashier 2/3 of the quarters and 3/5 of the nickels. That's really important. The cashier does not give her any change. How many cans of juice did she buy? So we got to figure out how much she spent. So let's figure out what 2/3 of the quarters, 3/5 of the nickels is going to equal. I set up a problem 2/3 of 15. Remember, 15 was my quarters. And I set up 3/5 of 10. Remember, 10 is my value of nickels. So now remember we did around the horn last week, boom, boom. It's a division problem starting with your whole number. Come to here, 15 divided by 3, get that value, multiply it through by 2, and you should be able to figure out what that value is for our number of quarters. Yep, it is 10 quarters. So 2/3 of our 15 quarters, 10 quarters. Now how much is 10 quarters worth? Each quarter is 25 cents, 4 quarters on $1, $2 is 8 quarters, so that is $2.50 on those quarters. Do the same thing with your nickels, multiply it through by the 5 cents per nickel, and add those two things together. Once you get that value, you can divide it by your 35 cents per can, that fact that we didn't use right away. So you take this value and then you're going to divide it by groups of 35, because that's how many cents each can costs. And that's how you figure out the total number of cans on that one. You can finish your scratch work on the back of the paper. Hopefully that helps you out and you can get your homework done tonight. Peace out.